Hello everyone, welcome back to Algebra 1-2. In this lesson, we are looking at the factor theorem, and so what we're going to be doing is looking at the factor theorem, what it is, and how to apply it. Now, the factor theorem, first we want to talk about quadratics and cubics rather. Quadratics and cubics are specific examples of what we call polynomials of degree n. So a quadratic function or a quadratic will be written in x to the square plus something else for argument's sake. So notice it's a polynomial of degree 2 because 2 is the highest power, while x to the third plus 3x squared minus 1 or plus 1 would be a quadratic of degree 3 because it has 3 as its highest integer power there. So in general, when we talk about a polynomial of degree n, what we're talking about is a polynomial of this form where x to the n minus 1 are our variables, and of course that goes down all the way to a constant if it has one. And these a to the n minus 1, a0, a1, these are the real numbers that act as the coefficients. And of course, a to the n can't be 0, because if a to the n is 0, then it won't be a polynomial of degree n. So this is the general form of a polynomial of degree n. And when we talk about the factor theorem, we are generally applying that theorem to polynomials of degree n. So how does the factor theorem work? Now, if 3 is a 0 of x cubed minus 5x squared plus 11x minus 15, so this is our polynomial of degree n. If 3 is a root, and it is, then x minus 3 is a factor of this. And if that is true also, then we can write our polynomial x to the third minus 5x squared plus 11x minus 15 as our factor times the quadratic that we get when we divide this cubic by x minus 3. So essentially, what we're saying then is if p of x is a polynomial of degree n, whatever that polynomial is, and has a 0 at x equal alpha, then p of alpha is 0, which is true, and then x minus alpha is therefore a factor of this. All right, of this polynomial of degree n. And we can rewrite our polynomial p of x as the factor times the quotient, and the quotient is always 1 degree less than the polynomial itself. So our factor times the quotient. Now, how can we prove it? It has a very, very simple proof. Now, if c is a 0, so let's say c is a 0 of the polynomial, and it is a 0 if and only if x minus c is a factor of p of x. They kind of work back and forth. So if c is a 0, then x minus c is a factor. If x minus c is a factor, then c is a 0 or a root. So if that's the case, then p of x can be written as the factor times the coefficient. And if that is true, if x minus c is a factor, then c is a root. So we can plug in x equals c and work that out, find p of c, then p of c will be equal to c minus c times the coefficient. And of course, c minus c here gives you 0, and 0 times q of c will give you 0, which goes back to saying that if c is a 0, then x minus c is a factor. So it's a kind of a simple proof that we can use to work through it. What we can do, though, is to use it, and it's very, very nice to use to factorize polynomials of degree n. Usually, we're going to stick to this polynomials like these. So how do we use it to factorize something like this? Well, what we look at it and we say, for example, what number would be a root? What number would give us 0 if we plug it in this? So you could start with 0. So if we put 0 here, then 0 minus 0 plus 6 would not give us 0. To be a root, we must get 0 for the answer. So let's try another number. Let's suppose we try x equal 1. Then if we try x equal 1, then what we're going to get is 1 to the third minus 7 times 1 plus 6. And you notice that that gives you 0. So 7 minus 7, that's 0. Which means now that if x equal 1 is a root or a 0, then x minus 1 is a factor. And what we can do here is that we can divide this cubic by our factor and get our quotient. So let's try to factorize this. Now what we're going to do, since we have x minus 1, we can use the synthetic division method. So x minus 1, we're going to start with 1 there and write out our coefficients. Now the coefficient here is 1. Notice that we don't have the square term, so we have to put in a 0 for that. And then negative 7 and 6. Now let's go ahead and draw our line there. Let's write the 1 and our plus. So 1 times 1 here gives us 1. 1 plus 0 is 1. Then 1 times this 1 is 1. I'm going to write it here. 1 plus negative 7 gives us negative 6. And 1 times negative 6 is negative 6. We add this and this and we get 0. So notice that we do not get a remainder here. And so our quotient is going to be, using 1 degree less than this, x squared plus x minus 6. So we can say now that x to the third, or x cubed minus 7x plus 6, can be rewritten as x minus 1 multiplied by our quotient, which is x squared plus x minus 6. And since we need to factorize it completely, we need to factorize this part. And this part is a quadratic. We can factorize it by breaking this x. This is a 1x. So 1 times 6 is 6. Also 3 times 2 gives us 6. And if we rewrite this as 3 minus 2, then we can get it there. So we have x squared plus 3x minus 2x minus 6. And then we can factorize here by grouping, by saying x into x plus 3 and minus 2 into x plus 3. And of course, that gives us x minus 2 and x plus 3. And so to factorize completely this, then what we have therefore is x minus 1 times x minus 2 times x plus 3. And there we applied the idea of the factor theorem to solving this, because once we found a number that worked, x equal 1 is a 0 or a root of this. Once you plug in 1, you get 0 for the answer. That means that it's a root. And if x equal 1 is a root, then it means that x minus 1 is a factor. And we can just go ahead and divide this using x minus 1. Here we use the synthetic division and found our quotient, which is this, and then we simply continue by factorizing this quadratic, which is our quotient. So it's a very, very interesting and nice theorem to know and learn, the factor theorem. Let's try it again. Here we have a second question that says, show that x equal a half is a 0 of this quadratic, of this cubic. A 0 also means that it's a root. Let's remember that. So let's show that x equal a half is a root. And what we need to find then is to find, let's call this polynomial p of x. And what we're going to do is to find p of a half by substituting a half into this. So we're going to have 2 times a half cube minus 3 times a half square minus 3 times a half plus 2. And how does this work out? This works out to be equal to 2 over 8 minus 3 over 4. This is 1 over 4 minus 3 over 2 plus 2. And as you realize, this is a quarter. And once you add up all of these, you'll realize that you're going to get 0. So we have shown that x equal a half is a root of this. And the thing now is that if x equal a half is a root, then multiply here, 2x minus 1 is a factor. So the question says 2x cubed minus 3x squared minus 3x plus 2 has 2 linear factors other than this. Find them and check to multiply to make sure that you get it, get back this expression here. So what we want to do then is that we want to divide out 2x cubed minus 3x squared minus 3x plus 2. This factor is not of the form x minus c, so we can't use the synthetic division. We have to use long division here. So let's set up our algorithm. We're going to divide by 2x minus 1. Now 2x into 2x cubed here will give us an x squared. And multiplying here will give us back our 2x cubed minus x squared. Very good. Let's do our subtraction. That's gone. And negative 3 minus a negative 1 here gives us a negative 2x squared. We can drop down our next term, which is a minus 3x. And 2x into minus 2x squared gives us minus x. So here we have a minus 2x squared and a plus x here. Let's do our subtraction again. This will give us 0. And negative 3x minus x will give us a negative 4x. 2x into 4x gives us negative 2. And we need to drop down that 2, carry down this 2. And so 2x times negative 2x squared gives negative 2x here, gives us our negative 4x. And negative 1 times negative 2 gives us our positive 2. So you'll see that we have no remainder. So this is our quotient now. This is our quotient, x squared minus x minus 2. And so our expression can be written as 2x minus 1 times x squared minus x minus 2. But we haven't found the other two linear factors, and what we need to do is to find them by factorizing this. So let us take this here and take it to another page where we can factorize it a little better. So let's copy that. Now let's make another page here, just a moment. So here we have our expression, and what we need to do now is to factorize this part. So notice that this part here is a quadratic, and so we can factorize it, x squared minus x minus 2. And 2 times 1 is 2, or minus 2 times 1 here with minus 2. So the numbers that we need to use here in the middle are negative 2 and 1. So we have x squared minus 2x plus x minus 2. And so we can factor out x minus 2 plus 1, x minus 2. And so our answers are x plus 1 and x minus 2. And so our expression would be written out as 2x minus 1 multiplied by x plus 1 multiplied by x minus 2. And so we have found our two linear factors, which are x plus 1 and x minus 2, which means that the other two roots that it would have are x is equal to negative 1 and x is equal to positive 2. The other part of the question said that we needed to find two other linear factors. We found them. Check that all three factors multiply to give the original cubic. I'm not going to waste your time doing that. But notice that if you should multiply, just go back through and multiply here, because if you multiply this times this, then you get that, and then multiply, then you get back the original cubic. So this is pretty much how we apply the factor theorem. First, you look at an expression, and then you say, okay, let's look at an expression x squared minus 2x plus 1. Then you notice that if you should put x equal 1 into this, then you would get a 0. So 1 minus 2 plus 1 would give you a 0. And if x equal 1 is a root or a 0, then what it would mean is that x minus 1 is a factor. And you could divide this expression by x minus 1 to get the other factor, so to speak. That's how the factor theorem works, and that's what it is. Now that you know, go get some practice and master it, and make sure that you get a very, very good understanding of it in the process. If you haven't subscribed, please do. Thank you for your support, and thank you for watching.